settings hierarchy. It holds configuration for the kernel state and for the applications that you operate. The system replaced the old INI files, arranging the data in a centralized style. The actual files that make it up are called hives, and upon system boot they're read from the drives. A hive is a file, a permanent store that Windows will load to the kernel's core. They're all found in a special system folder like system, slop, rail, drivers, and components. And end-user dat holds a user's own base located within their own profile space. Its structure is made of many nodes called keys, then values with data that the system might need. The structure begins with a set of root keys which logically organize these data trees. HKey local sheet is for system-wide stuff. For services and drivers it holds just enough. Then HKey current user reflects a user's own space. For settings unique to your account and interface, this key is a link, not a hive of its own, to HKey users where your profile is shown. The HKey user's hive will contain every SID for all of the user accounts that are not hid. Then HKey classes root is for file association, like which program to use for a file of type's creation. It's also a view that is merged and then made from machine and user classes, a data cascade. These top-level handles provide the main door to access the settings the system has in store. Within every key name values you can find, which hold specific data of various kind. Each value contains a name type and its data, a trip or type structure of key metadata. The types define how the data is stored, a format by which the value can be explored. Rexes holds a string of Unicode text, a simple value you would likely expect. Pretty word is for numbers, 32 bits in size, a common integer that often applies. For larger integers where 32 bits won't do, there's the 64-bit reg Q word to use. Red binary stores raw data and is often the norm, just bytes in a sequence with no real form. And reg multisys can hold many text lines, a list of null terminated strings you can define. The kernel's configuration manager will guide how registry data is accessed from inside. The hives are all loaded in memory space to make lookups happen at a much faster pace. A change to a key is a process atomic, so potential interruptions are not catastrophic. The system will flush out the data to disk to safeguard against a corruption risk. But this operation does not happen right then. It's managed by Windows again and again. A key has a last write timestamp you can check to see when a change was last put on its deck. The tool that you use for a manual peek is regedXC. Then for yourself you can see, but if you